So methane is produced by the decomposition of vegetation, and the waste gas is produced from digestion in animals.
Okay.
Right. And so, right, this is also a greenhouse gas. And so elevated levels would lead to global warming. So how do we alleviate the problem? Right. One is right composting or incineration. So composting is when you sort of bury the dead vegetation in the soil, and so then the decomposition happens in the soil, and so it actually makes new soil, right, instead of being wasted. Or incineration, which basically means just burn it, right? Then the methane could also potentially be used as a fuel.
How?
Also, huh?
How?
Well, burn it. So we've looked at the combustion of methane earlier on when we were doing what chapter was it again? Uh, Chemical energetics, I believe.
Yeah, okay. Yeah.
Right. So methane, is an organic compound. It is a sort of fuel, and so it can be combusted in oxygen to produce carbon dioxide and all that.
Yeah. Okay.
Right. So methane can be used as fuel,
Okay.
and then just discourage people from eating meat. So eat less meat. So how would that help? Presumably, if there's less supply demand for meat, there's less animals being farmed, and if there's less animals being farmed, then right, there's less methane being produced by those animals,
Okay.
right? Because obviously you have an artificially high number of animals on poultry farms. In the wild, they would not grow to those numbers, right?
Yeah.
Okay. Then you've got nitrogen oxide, right? And it says oxides, so there's multiple, right? It's not just one. So them, right? They are caused by, they are a waste gas or coming from car exhausts. So they're coming from car engines, which basically means they're a waste product or a byproduct of combustion of fuel,
Yeah.
and right, they can cause respiratory problems,
Okay.
right? They contribute to something called photochemical smog and acid rain, right? And again, right, how do you solve the problem? As far as cars are concerned, you fit in catalytic converters. And so what they do is, I'm putting an X over here, that means some combination of these two.
Okay.
And so what that does, it converts the oxides of nitrogen. They're either called nitrogen oxides or oxides of nitrogen, whichever you prefer, to just simple nitrogen. There's something else that happens. We'll talk about that in just a moment. There's something else that's happening as well. But as far as the nitrogen is concerned, it's converted into nitrogen gas, right? And so there's nitrogen gas in the air anyway, and so that's not harmful. Okay.
Yeah. Yeah.
And
Okay.
then finally you have sulfur dioxide, right? SO2.
Yeah.
And this is coming from the combustion of fossil fuels containing sulfur.
Okay.
It contributes to acid rain. And how can this be controlled? You remove sulfur from, petrol, for example.
Okay.
Right? And there's something called uh, flue gas desulfurization. Flue gas desulfurization. So that's also a process that we'll talk about, FGD. Okay. Now, right, with all of this and the mention of catalytic converters, you got, right, what's happening in catalytic converters. Very briefly, you can get the detail from the text, right? As I
Yeah.
mentioned, I'm trying to complete the chapter in this class, so right, we don't leave it hanging during winter break. And so a catalyst such as platinum or palladium or rhodium is used in these converters. So it's mostly platinum, but it could be palladium or rhodium catalyst or catalyst. And what that does primarily is it takes nitrogen 2 oxide, a bit of chemistry over here,
Yeah.
and it takes the carbon monoxide and it converts that to nitrogen and carbon dioxide. So we're not solving the problem, we're just lessening it, right? So I'm going to write out a balanced equation. You got 2NO, which is a gas, plus 2CO, which is a gas. All of these guys are gases. And you're getting N2 and 2CO2. Right? And so carbon monoxide is also toxic. Nitrogen oxide is also harmful. And so what the catalytic converter is doing basically is it's taking the oxygen away from the nitrogen. So nitrogen is being reduced, right?
Okay.
This is reduced because it's a loss of oxygen, and the carbon monoxide is oxidized to carbon dioxide. And so at least, right, nitrogen is there in the atmosphere anyway. So is carbon dioxide. Of course, having putting more carbon dioxide there is not helping, but it's not as bad as carbon monoxide. And so that's what's happening inside catalytic converters. Okay?
Yeah. Okay.
Yeah. There are other oxides of nitrogen as well, such as nitrogen 4 oxide, which are also formed inside car engines and stuff like that, right? And when the fuels are burned at very high temperatures, okay?
Yeah.
So, yeah, that's all about catalytic converters. And
Okay.
okay, now one problem that, well, like one solution that they have is, like, get rid of fossil fuel based engines, like, anyway, and use electric motors.
Yeah.
So replace petrol based engines with electric motors. Now, how do you do that? Obviously, right, that's the question. We're not going into detail, but it should be at least theoretically better.
Okay.
Right, we talked about the particulates, and so, right, those are obviously harmful. Then there's acid rain, right? So how does acid rain occur? And so I already mentioned that like natural water is slightly acidic due to dissolved CO2, right? So CO2 dissolved in water will give you carbonic acid, which will make it, so it's a weak acid, so, right, slightly acidic. But if you've got raised levels of carbon dioxide, then that's going to affect the acidity. Then plus you've got sulfur coming out of, industries,
Yeah.
right, power stations, and you've got, right, so you've got sulfur dioxide emitted from industries and power stations. So what happens is that the sulfur dioxide dissolves in with the rain. So when it rains, right, this dissolves in rainwater
Okay.
and it forms sulfurous acid. Sulfurous acid, which is H2SO3. And then, right, this is further oxidized to sulfuric acid, which is even worse. Then you've got, right, uh, oxides of nitrogen. So you've got nitrogen 4 dioxide.
Okay.
And so that looks like, right, NO2. Okay. Nitrogen oxide was NO. This guy is NO2.
Yeah.
And so this dissolves in water, in rainwater, to form nitric acid. which is HNO3. We've got, right, carbonic acid, you've got sulfuric acid, you've got nitric acid, and so obviously all these pollutants are really creating big problems. Okay. Now
Yeah.
there's some countries of the world where there's a lot of pollution and there's like, lots of industries, and so you would expect that they would be suffering from this problem more than other countries, right?
Yeah.
Okay. Then, right, we talked about flue gas desulfurization.
Okay.
FGD. And so what happens over here is, right, in power stations, the sulfur dioxide gas is removed by passing it through a mixture of calcium oxide and water. So emissions, and emissions basically means the waste gases are
Yeah.
passed through a mixture of calcium oxide in water. Okay. And so what this happens is it removes the sulfur dioxide, which is good, obviously, and it forms calcium sulfite.
Yeah.
Right? And calcium sulfide is then further oxidized to calcium sulfate. And how is that good, right? It's that is used to make something called plaster boards.
Okay.
So this, right, flue gas desulfurization is expensive. So, right, getting calcium sulfate at the end and being able to sell that to make plasterboard sort of offsets the economic aspect of the cost of the process. So, at the end of the day, even pollution and getting rid of pollution all boils down to profits, right? If there's any profit to be had by going through the trouble of removing pollutants from the air, then it's something that the industry would go for. Otherwise, who cares?
Yeah.
Okay. Lastly, this took a bit longer than I thought it would, but right, global warming. So let's do this. Right. So what happens is that pollutants, some of them are greenhouse gases. And what they do is basically, right, you've got light and heat coming in from the sun, right? So some of it is reflected back by the Earth's surface, some of it is used up, and some of it is absorbed by the earth. Right now, this guy, when it is again released, and even the one that is being reflected, right? Remember we talked about uh, conduction and radiation, right? So when in physics, so when, right, the heat is radiated back, what happens is that the gases such as carbon dioxide and methane, right, in the atmosphere, they sort of form like a cover around the earth, right? So this is the earth, and then you've got, right, these gases in the earth's atmosphere. And so when you've got light from the sun coming in, it does come in.
It's like ozone layer, right?
No. The ozone layer protects you from harmful radiation. What the greenhouse gases are doing is that they're preventing the heat from escaping. And so the heat stays inside. So what would happen when the heat stays inside?
It would be kind of harmful, wouldn't it?
It's going to get hotter, right? It's like
Yeah.
sort of when you order food from outside, and they put it in an aluminum wrap, and then they put it in either like a styrofoam box or a paper bag. Why do they do that? Right? Is because the paper bag or the styrofoam is going to insulate, uh, right, your food, and so it won't get as cold as quickly as opposed to if you were just
But it
holding it.
traps it inside.
Huh?
It traps the heat inside, right?
Yeah, so it traps the heat, right? And so heat is trapped, and that obviously raises the temperature globally, right?
Yeah.
Now, why are these greenhouse gases, right, increasing? So first of all, it's deforestation. So forests are being cut down. So deforestation. So when you don't have plants using up carbon dioxide, that's going to be a problem, right? Then you've got the
Yeah.
pollution of rivers. You want to add something?
Nope.
Okay. The pollution of rivers and oceans, right? So even rivers and oceans, right, they absorb carbon dioxide, and so, right, if they're polluted, they can't absorb carbon dioxide as well. And then, right, obviously, increased emissions of carbon dioxide. And for, right, so this is all for higher CO2 levels, because, and for methane we already talked about, because of, animals and, livestock farming and all of that. And so what would happen because of raised temperatures, right? Ice, the polar ice caps, the North Pole and the South Pole, they would melt. When they melt, they turn to water. That would increase the sea level, and that would cause flooding. Okay.
Yeah.
So higher temperatures, right? Melting of polar ice, right? Increased sea levels, flooding. Right. Additionally, what's happening is we talked about particulates, right?
Yeah.
So what these particulates do is that they travel to these areas that have ice, and then they get mixed with the ice and the snow. And so what that does is ice is white, and so it is reflective, right? So it reflects light and it reflects the heat of the sun. If it is mixed, you got this black sooty material mixed in with the ice, so the ice will also turn black. And black is not reflective, as you've talked about in physics. Black is a good absorber of heat, and so that is problematic.
Yeah. Okay.
Right?
Yeah.
Okay. How can we reduce this? Plant more trees, right? Burn fewer fossil fuels, so use less fossil fuels, right? It's given in detail in your text, so you can read through it, right?
Yeah.
And use renewable energy.
Okay.
Be more energy efficient. So an example of this, I'm tying this in with physics, right? For example, you are using insulation during winter, or insulation in general, right? And so if you're using insulation in winter, your building stays warm, and so you don't need to burn fossil fuels to provide heat inside, right? And the cold doesn't affect you as much, for example. Okay.
Yeah.
Use renewable energy sources, reduce livestock farming.
Okay.
Right? And finally, right? In fact, before going to the finally, so what these greenhouse gases are doing, it just occurred to me to say it this way, is they're sort of forming an insulating layer around the earth, and that's not something we want. Just like the ozone is a protective layer, so we want that layer to be there.
Yeah.
It's protecting us from harmful radiations.
Yeah.
The greenhouse gases are forming an insulating layer, and we don't want that because it's causing the planet to heat up,
Yeah.
right? So it causes insulation, and we don't want that. And insulating, right? Greenhouse gases form an insulating layer. Okay. Now going to the finally, they are suggesting alternative fuels. And I'm just mentioning those fuels and I'm going to talk about them verbally. So this biodiesel, and it is something that can be made from waste plant material and animal oils. It produces less of these pollutants, and the emissions are not higher than regular fuel, right? So that's an alternative. Then there's ethanol. Will it work? Is it sustainable? Well, right, it needs a large, area of land to cultivate sugarcane to get sugar juice, like sugarcane juice, which will be fermented to produce ethanol, and so perhaps it's not as viable, right? It produces less uh, pollutant gas, and because it's a plant, it is taking up carbon dioxide from the atmosphere, so that's a good thing. The problem is that it's very flammable, right? So it can ethanol is flammable, so that's a problem.
Yeah.
And finally, you have hydrogen, right? So we've talked about hydrogen fuel earlier as well, and so right? It is renewable, and right, the only waste, so to speak, produces water. The problem is that it is very flammable, and right, you need a high pressure tank to store hydrogen, right, in a liquid form. So what you need is liquid hydrogen, right, not gaseous hydrogen. So you need a high pressure tank. And also the problem is that to get sufficient amounts of hydrogen, we talked about the electrolysis of water. So that's how you get hydrogen gas. And so that's an expensive process. And so there's just the amount, the volumes of hydrogen gas that you would require for this to actually work, perhaps is not as feasible. Okay.
Yeah.
So all of that is
Yeah.
given in a table at the end of the chapter. And congratulations, we have completed chapter 11, which is chemistry of the environment. So
Yeah.
after the winter break, we will begin with organic chemistry.
Oh God.
Why?
Uh, that sounds pretty hard.
If you pay attention, it won't be.
So it is hard.
Students tend to find it hard, yes.
Okay.
Right?
Yeah.
Many of the times, what students tend to find hard is just because they have this, you know, concept, this idea in their mind. Oh, it's hard, and so without even trying, it becomes difficult, and then they just don't pay proper attention.
Yeah.
All right. So
Uh,
see you in January, inshallah.
inshallah. Okay, Allah Hafiz.
Allah.